So I'm from Wisekey. My name is Max. Wisekey, what's Wisekey? Wisekey, sorry, I will stand not in a way. Wisekey is a company since 20 years. We make digital identities, and we do that through certificates and managed PKI systems, public key infrastructure. We do this from out of Switzerland. We do digital identities for people, for web services, for contracts, and for objects. And for objects, we do digital identities through secure elements. So we have about 20 years experience in this stuff, and we have a lot of customers which trust us to handle their identity. So that's for the intro. So of course we all know the Internet of Things. It's amazing. It's about 50 billion devices would be connected in 2 years from now. And well, we analyze the data. We all get richer and healthier and so out of it because well, it's simply amazing. And we all make big bucks because it's so cute. But unfortunately, in the press, we read other things. Of course, we read about nice things, nice programs that come off the floor and that will be implemented, but then we get this kind of messages. Hacks. Things will break down. Things will be hacked. And we see a lot of them, and there are more and more. Really a lot of them. So that means that attacks are happening. It's on the internet, it's out there. People are scrutinizing and people are trying to attack every day, every time, while I'm talking. It's not a question if, but it's a question when it will be attacked. For some years ago, it was a question of whiz kids playing around in their garage and just trying to fool around and to try to get into something, while it's now moving towards organized crime. Organized crime because they can make big bucks out of it. So they will scrutinize the web, they will get into things, and they will look for openings, they will look for attacks, and once they found something, they will put it on the dark web and they will sell the attack. So you can buy an attack, you can tailor it for your needs, and then you can attack somebody or something with the attack you just bought. So this is a really big business. So, like I said, it's not a question if, but it's a question when. You will be attacked if you do IoT. So, these attacks, of course, are on system level. It's a question of just seeing what's passing over the internet and look what I can do with this. I can go into servers, I can go perhaps into devices, I can download software, etc., etc. And this is all done from out of my comfortable chair at home where I can attack through internet. There are also attacks possible on a device level. I have a device, I can open it, I can see what's happening around. I can put a probe somewhere and I can see what the power consumption is. I can see what the electromagnetic radiation is. I can G-tag, for instance. I can go for the G-tag for test points and I can see what's inside the memory. And with this, I can really find a lot of things. And on our table, which is over there, we have a demo to show you how easy it is to get into non-secure microprocessors that are supposed to hold secret keys. I think it takes up to 20 seconds. I asked my colleague over there who's an expert. Even less than 20 seconds and we can find an AES key which is held by this system. So, 50 billion devices, a large chunk of it will be LoRa. LoRa will be present, I saw it over there, in a lot of very interesting markets. So it is really a very interesting attack surface for people who want to harm somebody. LoRa will be attacked, and the systems using LoRa will be attacked. So, it's an ideal playground for hackers. So what I want to say here is that you can implement an application on LoRa using the LoRa network, but you might need to think a little bit more about what would be the risks. What am I exposed to with my system? So I need to have a threat analysis. And from the threat analysis, I can determine what would be the cost of an attack. And I think of liability. I can think of brand image loss. I can think of lawsuits or that kind of stuff. I can even lose my business just because the money I have to pay to somebody. So this is a threat analysis that should be done, and the conclusion of this threat analysis should determine if the LoRa security is enough, or should I do something more? And even the LoRa specs themselves, they say it in, I think it's chapter 6123, or 6321, whatever. Additional end-to-end security solutions might be used if you need so. So then there is one more thing, and I just talked about that with another people on our table, that security should be done from the start. It's done in the design of the device. There you should start thinking about security and implement the chips you need. So if you go now to what we are doing here, why am I telling you this? This is just an ordinary LoRa network as far as I understand LoRa. I'm not an expert in LoRa, I will tell you immediately, but this is the LoRa network. What we propose is, on the left side, secure element to store all the secret assets you want to take care of in your device. And on the right side, it's a managed PKI solution, which will help you to manage, to control these assets which are in the device. So the secure element will be stored in the device. It will be, of course, soldered on the PCB, and it's called Volt IC405. Volt because it's a thing that protects the keys. It's an IC, an integrated circuit, and 405 it's just because it's just after 404. No, it's just a number. So it holds the critical assets of the device. We can think of the specific LoRa keys, but as well it will contain a digital certificate, private keys, certificate of the host device. It will do the algorithms needed to use these keys, to do the technical digital signature using elliptic curve cryptography, for instance. It will encrypt data using AES, Advanced Encryption Standard. And of course, it holds the keys for this stuff. It has a true random number generator. So in security, if you need to know one thing in security, that is you need to have a true random number in order to generate secrets. If you don't have a true random generator, it will be broken. So we have a true random number generator. And it offers tamper resistance to all kind of physical attacks which people use to get normally things out of microprocessors. Just to highlight a bit the difference between a non-secure microprocessor and a secure microprocessor. Non-secure microcontrollers, they are weak. They are designed for performance. They are running multiple applications. They have a memory which is accessible to the applications. You can access it by the external, from the external. And they don't have any control about which temperature they operate in, which is the voltage, etc., etc. Typically, the hacking cost is less than $10,000. I would even say the demo we show you there, I think it's $2,000, not even. Compared to secure microcontrollers like we make them, they are tamper resistant, so they control the environment. As soon as the chip detects that the power, for instance, goes out of the designated range, it will stop. As soon as it detects that the voltage is out of the the temperature is out of the designated range, it will stop. The design of the chip, of the silicon, is made in such a way that you cannot access the memory from the outside. There are no test access GTAG available for the user. You cannot access the chip. There's only one application running, one application that is meant to do the signatures, to do the algorithms, etc., etc. It's well, we have on our chips more than 20 different security measures. So as soon as the chip gets attacked, it will just stop and reset, and there's nothing to get out of it. This way, it will take more than $10 million to get into the chip. They are certified. We have laboratories scrutinizing this chip. We give them everything they want to know, the data sheet, the design sheets, the chip itself, and they will play around with it for months. And after some months, they say, okay, we give up, we cannot get into it. Which is not at all the case for non-secure microcontrollers. They will use 2 minutes and they will say, we get into it. So a device should be typically implemented like this. We have on the left side the device microcontroller doing all the application stuff, all the neat stuff you want to do with LoRa. And it holds a secure microcontroller to use the secure assets, to hold the secure assets and to use them. And this is the best way to implement the device. You don't lose any performance. You will lose a little bit of space because the chips, even these are tiny packets, they take some place. it's slightly a little bit more power consumption, and still that has to be proven because you don't use the microcontroller to use the complicated functions like AES or elliptic curve. It will be done as a microcontroller. So this is the best architecture to implement for a device. And now we go back to the other side of the picture. The other side is the Managed PKI System. Why do we need that? If we have a private key and a digital certificate in the device, we need to know if this digital certificate is authentic. So that we need, on the other side, we need a root of trust. The root of trust will sign the digital certificate. So we have a root of trust. We have a security broker here, which is the part on the back end which will take care of the encryption and the decryption and the authentication of the devices, which are on the other side of the web. We have the certificate management system, which will allow the operator to check the status of certificates of the devices, to revoke them, to change them, to reload them, whatever, to manage the device from a distance. The entity management and the entity attributes will help you to control your devices, to control the life cycle of the devices, for instance. So you can, using the attributes which are signed, you can, for instance, control the whereabouts of the device during production. If you have several production sites and several OEMs or in a chain of OEMs that build the device, you can know exactly where the product is, and there is no gray market. You can imagine that your devices will be produced by a company who just takes away some devices and sells them in their own name. So you can avoid this with kind of Volt IC inside. And the system will allow you to have secure firmware update. So I'm not talking about the firmware itself, but at least the firmware will be signed by our system, by the backend, and will be sent to the device where the Volt IC, the secure element, will be able to check the signature of the firmware, and only if the signature is valid, it will be downloaded on the device. So this will avoid people to download some fake or some botnets in your device and use the device for other means than it was intended for. So typically this gives you this architecture, the devices with the secure element and your application server with the PKI system connected to it, which gives you an independence of the network security of LoRa itself. So you have strong authentication through digital certificates. You will get real end-to-end confidentiality. It's really going from the device up to the application through all the different LoRa networks you might encounter. It will simplify the burden of secure key handling during manufacturing, because if you have keys to handle in your device while you manufacture it, how do you do that? How do you want to keep your keys secure? How do you know that the guy who is putting it into the chips, he's not selling the list of keys to some third party just because they got a lot of money for that? That happened already in the past, and it will continue to happen. And we have secured storage of keys and credentials. So once the device is on the field, we are not afraid that the keys will be stolen just through a small device, which you can see on our table. I invite you to hop over and to see how easy it is to steal the keys if you don't use a secure element. So apart from these four obvious security things, we add things like secure device boot. We can encrypt the code and we can sign the code, and then as soon as the device boots, it will check the signature of the firmware and only boot if the boot is okay. Goes with the secure firmware update, of course. The device lifecycle management, what I told you about knowing exactly where the device is and in what state it is. And we don't have tampering or cloning of your device, so it will protect your IP, it will protect your market. So basically, that's all I wanted to say. We offer a solution that goes beyond the basic level proposed by LoRa. So you have increased trustworthiness. Your applications are secure. You have an improved brand image out of that. You will have top-notch remote control of your devices. And you have complete network independency. So that's what I wanted to say in Amsterdam.